Welcome everyone. Today we are going to start a new chapter and one of the very important and basic chapter of the chemistry, that is about the atomic structure. We will divide this chapter into three portions. In the first portion we will discuss the subatomic particles. In the second portion we will discuss the models of atom, and in the third portion we will discuss the distribution of electrons in an atom. So without wasting time, let's move towards the subatomic particles. Before the proper discussion of the subatomic particles, I will like to mention one thing, that we have already studied that during the Dalton's time, atom was considered as the smallest particle of matter. But nowadays, it is very clear to us that atom is not the smallest particle of matter, but there are certain particles that are even smaller than atom that make an atom, and these particles are called as the subatomic particles. Now, there are more than 100 subatomic particles that have been discovered so far. But out of these 100 or more than 100 particles, electron, proton and neutron are considered as the fundamental particles. And when we study the atomic structure, our main focus is also on these three fundamental particles. So let's start our discussion from the electron. Now the electron symbol E minus or even beta minus is used for electron. How the electrons were discovered? Who discovered the electrons? Let's move towards this. Basically, the discovery of electron is related to the discovery of cathode rays. So discovery of electrons, that is related to the discovery of cathode rays. Now how the cathode rays were discovered? The cathode rays were discovered by Sir William Crookes in 1870s. Sir William Crookes, he is famous for three things in the history. The first one is the discovery of the element thallium, which is nowadays in the modern periodic table is an element of group 3a. The second is the discovery of plasma, and the third is the discovery of cathode rays. Sir William Crookes, when he discovered the cathode rays, he used a glass discharge tube. This was the apparatus basically which was used by Sir William Crookes. This is a glass discharge tube. You may call it glass discharge tube, or it may also be called as the Crookes tube. It is made up of glass. That's why it is called as the glass discharge tube. Now, why it is called as discharge tube? Because discharge tube is a tube in which we can adjust pressure up to our desired value with the help of this vacuum pump. The main purpose of attaching the vacuum pump with this glass tube is to adjust the pressure and to study the cathode rays at different desired pressures and to see the behavior of the cathode rays. So a tube in which we can adjust the pressures, that is called as the discharge tube. Now it is clear why it is called as glass discharge tube. In this glass discharge tube, a gas is filled at low pressure. Now which gas should be used? You can use any gas, whether air, helium, hydrogen, nitrogen, any gas can be used in this glass discharge tube. But the pressure of that gas, it will be kept very low. And what is the pressure. What is the value of pressure that was used by William Crookes during the discovery of cathode rays? Actually, William Crookes used different pressures to study the cathode rays. But in our books, it is written that the pressure is 0.01 torr, which is used when the Crookes studied the cathode rays. Similarly, this one is a high voltage source which is connected to two metallic plates. The plate which is connected to negative end of this battery or high voltage source, that is cathode, and the plate which is connected to the positive end of this high voltage source, that is called as the anode. This voltage source provides voltage from 5000 to 10,000 volts. This value is written in our books, 5000 to 10,000 volts. We can vary the voltage. Now listen very carefully that what voltage we will be using, it will depend upon the length of this glass star tube and the pressure inside the glass star tube. So William Crookes used voltage, and in our books it is written 5000 to 10,000, and even in some books it is written that 10,000 volts was used. We can also write it as 5 to 10 kV, kilovolts was used. So this is the construction of this Crookes tube. Now, how the cathode rays were produced? Actually, when a gas is filled at a very low pressure in this glass discharge tube and high voltage is applied, it is observed that some radiations travel from cathode to anode. And these radiations, because they travel from cathode to anode, these are called as the cathode rays. The question is whether these cathode rays are produced by cathode itself or there is some other source of the cathode rays. Nowadays, it is very clear to us that cathode rays are basically electrons. They are the group of electrons moving at a very high speed. And even when we are discussing the radioactivity or nuclear sciences, these cathode rays or high moving electrons are called as the beta rays. Now, what is the origin of these cathode rays? The question is, origin of cathode rays. Cathode rays are electrons. From where these electrons come? There are three sources of these electrons. The first one is free electrons due to photo-ionization. Listen very carefully and keep this thing in your mind that every gas naturally consists of some free electrons. From where these free electrons come? Because when the sunlight falls on a gas, some of the atoms of the gas are ionized under the influence of the photons of light. This ionization is called as photo-ionization. And this photo-ionization produces some free electrons. Although these free electrons are very few in number, but they are. When a gas is enclosed in the glass star tube, that gas will also be consisting of these naturally occurring free electrons produced due to the photoionization. So first source of the electron is the photoionization. The second source is knocked out electrons. The free electrons, because of photoionization, when we apply high voltage, those free electrons are accelerated. And when those free electrons are accelerated, they strike with the electrons of the gaseous atoms. And some of the electrons from the gaseous atoms, they are knocked out, producing the cations and the free electrons. You can write it down in the form of an equation that suppose there is M gas. This one is the free electron. These free electrons are the accelerated free electrons which were produced because of photoionization. When they strike with the gaseous atom, they knock some electrons. The positive gaseous ions are produced. Along with it, these are the free electrons and these are the knocked out electrons. Now the free electrons are accelerated, they are moving in form of groups, and these knocked out electrons are also moving in the form of groups from cathode to anode, and these make the cathode rays. The third source of the cathode rays, that is cathode itself. What does it mean? When these positive ions are created in the glass discharge tube, these positive ions will be repelled by anode and they will be attracted by cathode. These positive ions with a high velocity, they will collide with the cathode, and some of the electrons from the surface atoms of this cathode are knocked out. And these electrons also move in form of groups, making the cathode rays. So cathode rays are the group of electrons, and these are the three sources from where these electrons originate. This was the origin of the cathode rays. I have said that pressure in the cathode ray is kept very low. Now the question is, why do we keep this pressure very low? Because every gas is conductor at low pressure. Let me explain this. That if the pressure inside this tube is very high, mean more gaseous atoms are present in it, then don't you think that the cathode rays will not be able to safely travel from cathode to anode, but in their journey they will keep on colliding with the gas molecules which are present in the glass discharge tube. When the cathode rays will not be able to freely move, obviously the conductivity of gas will decrease because that is offering hindrance to the flow of the charge. So its conductivity will be decreased. In order to make the journey of the cathode rays clear and safe from cathode to anode, we have to take very low pressure inside the glass discharge tube. When in the start of the lecture I said that Sir William Crook discovered plasma, don't you think that the plasma is already created in this glass discharge tube? And that was plasma which was reported by Sir William Crook. What is plasma? Plasma is a mixture of neutral gaseous atom, cations and free electrons. And obviously all the atoms, gaseous atoms in this glass discharge tube, they are not ionized. So this glass discharge tube now has a non-equilibrium mixture of neutral atoms, free electrons and gaseous cations. So this glass discharge tube is basically having plasma in it. From this diagram, maybe it will be somewhat surprising for you that the cathode rays are traveling straight. Why they are not bending towards this anode? Because these cathode rays are highly accelerated. They are having high energy, and even I have listened and I have read somewhere that in some books that these cathode rays travel with the speed of light. Their speed is very less as compared to the speed of light. Because these cathode rays are highly accelerated, so they will pass by the anode and they will move straight and they will produce fluorescence when they will strike with this glass. How these will produce fluorescence? Obviously when cathode rays will strike with glass atoms, some of the electrons in these glass atoms, they will be excited, and when those electrons will be de-excited, the glow or fluorescence will be produced. And in the Crookes tube, the greenish glow is produced. So this was about the discovery of the cathode rays. Now the cathode rays are discovered. The next step is to study the properties of cathode rays. So let us discuss the properties of cathode rays. The first property, whether cathode rays are charged or neutral. Whenever we want to check whether some particle or radiations are charged or neutral, we pass those radiations through magnetic field. If the radiations pass straight through the magnetic field, they will be neutral. But if the radiations are deflected in the magnetic field, they are charged, because magnetic force only operates on the charged particle. When the cathode rays were passed through the magnetic field, they were deflected. This line is very important. They were deflected perpendicular to the direction of magnetic field. This was a confirmation that they are charged. Now, what kind of charge? Positive or negative? This was the question. When you want to test whether the charge is positive or negative, apply the electric field. Here the two plates were used, positive and negative, and when cathode rays, they deflected towards the positive plates, showing that they are negatively charged. Third, cathode rays cast shadow. Always keep one thing in your mind, that only those radiations can cast shadow of any opaque object that travel on a straight path. If the cathode rays also cast shadow of the opaque objects, it simply means that they also travel on the straight path. Fourth, they are ionizing radiations. They can ionize gases, yes, because when fast moving cathode rays strike with the valence electrons of the gases, they knock out those electrons and the gaseous atoms are changed into the cations, so cathode rays can ionize gases. Cathode rays have reducing effect. Cathode rays consist on electrons. When they hit any object, they deliver some of electrons to that object. So that object is reduced and they have reducing effect. Produce fluorescence. As I have already discussed that they produced fluorescence in the glass discharge tube, and that fluorescence was greenish yellow or green. When alumina is placed in their path, it glows red. Similarly, the tin stone glows yellow when it is placed in the path of the cathode rays. And that fluorescence is just due to the excitation and de-excitation of electrons. Cathode rays possess momentum. How it was confirmed? When cathode rays are made to strike with a small wheel, the wheel starts rotation. Cathode rays have created that movement in that wheel, and cathode rays can create movement, or any radiation can create movement in some other object if they possess momentum. So the rotational motion of that wheel due to the collision of the cathode rays is a proof that cathode rays have created this motion and they possess momentum. Now momentum is equal to m into v. So here is another problem. It means cathode rays are not massless. If they were massless, they must have no momentum. But if they have momentum, they are not massless. It means cathode rays are not pure radiations. They are something else that we know called that these radiation consist on particles which are electrons. Eighth, cathode rays when strike with a heavy target metal, they also produce the X-rays, and this will be discussed in the topic of X-rays, inshallah. Ninth, E over m value. E over m value is basically charge to mass ratio. The charge to mass ratio of cathode rays is same as that of electron. This also confirms that cathode rays consist of electrons. And a very important point, that this charge to mass ratio doesn't change, doesn't depend on the nature of the gas which is used in the glass discharge tube. And in case of every gas, electrons or cathode rays are produced. Because cathode rays consist on electrons and electrons are same in all gases. So how the E over m value can change? But in case of every gas, the cathode rays are produced. This proves that electrons are the fundamental particles and they are present in all matter. Now, let me tell you one thing. Cathode rays were discovered by Sir William Crookes. Electrons were discovered in 1896 or 1897. Both these are found in the books. They were discovered by J.J. Thomson. The name electron, the books say that that was suggested by Stoney, but I have some reservation on that. That Stoney was an Irish physicist. In 1891, he used this term electron. 1891, but the electron was actually discovered in 1897. So the particle was later discovered and the name was first given. How is it possible? According to me, according to my research, and according to my very humble request, anyone can differ from it. It is my opinion that Stoney basically named electron, and he named electron to that charge which was traveling from cathode to anode. He didn't name electron to those particles that were making the cathode rays. Basically, the name electron was suggested by H.A. Lorentz. H.A. Lorentz suggested that cathode rays consist of electrons. He named electrons to these particles, but Stoney named that charge the electron. Even there was a time when the electrons were, this word electron was not used, but the negatron was used. Negatron was just used to show that these particles are having the negative charge. This was all about the discovery of cathode rays and how it was observed that cathode rays are not pure radiation, but they consist of electrons, and electrons were also discovered. I hope so that the concept is quite clear to you people. Your suggestions in the comments, I will highly appreciate them. So thank you so much for your love and affection that you have shown to me. Allah Hafiz.